So what are we working on tonight?
Solving quadratics with radicals, kind of.
Okay. Go ahead and
All right.
give me the problem. I'll write it.
All right.
I'm ready.
All right. Root 4x plus 25 equals 7.
Is the x inside the radical or out?
Yes.
Inside.
And the 25 is inside as well. And then equals 7.
Like this?
Yes.
Okay. So we always want to get rid of the radical sign. In other words, we want x equals something at the bottom.
Mm-hmm.
So what do we do first?
Square both sides.
Okay, so what's the next line?
4x plus 25 equals 49.
Next line?
It would be 4x equals 24.
And the next line?
X is 6.
Now let's just check, make sure. When we plug it in, we get the square root of 24 plus 25, which is 49. The square root of that is 7.
Right.
All right, what else?
Hold up. My problems are bugging out.
What's that?
It's giving me trouble here. Hold on. Alright, here it is. Alright, so in parentheses, root 2, and then out of the radical sign, minus 7 in parentheses squared.
Okay. So what does this mean?
There's 2 of the...
Means we're going to take this thing and multiply it by the same thing.
Mm-hmm.
We're going to use FOIL to do it. So what's the first term?
Would it be...
What's root 2 times root 2?
Root 4?
Well, don't look at it like that. Root x times root x is x. It's not root x squared. It is, but there's no reason to interject that other step into it. In other words, root anything times root the same thing is the anything.
Okay.
So it's automatically 2. It's not root 4. You don't, that's inefficient step. Okay. What's the second term?
What? It would be...
What we just did was this times that.
Uh-huh.
Now we're going to do this times this.
So minus 7 root 2.
Now we're going to do the inside.
So another negative 7 root 2.
And finally, we're going to do the outside, the last.
That would be negative 7 root 2. Or, sorry, plus 49. What?
Okay. Now simplify. We've got some radicals and we've got some numbers. What do all the numbers total?
The numbers, they total 51.
And what are all the radicals total? What's that?
Negative 14 root 2.
That's it. That's your answer. Okay?
Alright.
Alright, what else?
All right. Here's one, I guess. So the question is, simplify. So this is just simplifying the radicals. So it'd be 5 root 48 plus root 75 minus root 32.
Like that?
Yeah.
Okay. So, let's start with that one.
Okay.
Simplify that. Start by doing the factors.
So 16 and 3.
Okay. Now simplify that further.
20 root 3.
So all the further we can simplify that term. So let's go to the middle term.
25 and 3.
Okay, so what does that become?
5 root 3.
And the last term.
16 and 2.
Which becomes?
4 root 2.
Okay. Simplify, there's another simplification we can do. Combine like terms, in other words.
Oh yeah, 25 root 3 minus 4 root 2.
Yeah, and that's as far as we can take it. You can't do anything with an apple and an orange.
Mm-hmm.
Okay. Hold on 1 second. Sonny, you okay? Come on now. Come on. Turn the light off. All right, go ahead.
All right, here's one. So x minus 2 equals root 2x minus 4.
First step.
Square both sides.
Okay, so what's the next line become?
That would be x squared plus 4x or minus 4x plus 4.
Good. And that's the way you want to learn how to do those. In other words, you want to do them in one step. You don't want to FOIL it and then have to combine the two middle terms. Because whenever you're squaring a binomial term, it always comes out to be this way. Okay?
Mm-hmm.
What's the right side become?
2x minus 4.
Next line.
It would be x squared minus 2x.
Hold on.
Equals 0.
Make sure you get the signs on your x's right.
Oh, minus 6x. Equals.
Hold on.
Or plus 8, sorry. Equals 0.
Okay. You'd hate to know how to do a problem and miss it because you didn't subtract minus 4 minus 2 correctly.
Yeah.
Okay, now what?
We'd factor that, so it'd be parentheses, and it'd be x, both, then it'd be -4, -2.
Meaning your solutions are?
4, 2.
Now, whenever you have an equation that has a radical sign in it, like this, you always, especially when you come up with two solutions, you always want to check both solutions. Because sometimes one of them won't work. and you throw it out. Because remember the rule of algebra, it doesn't say that both of those have to be 0. It just says one of them has to be 0.
Mm-hmm.
So, does 4 work?
4 would... No.
Well, 4 minus 2
is 2, and
is
then...
equal to the square root of 8 minus 4, which is 4.
Oh, yeah, it does work.
It does work, okay. So that one works. Does 2 work?
No. Or...
Why not? Can you take the
Because you
square
can't
root?
square root of a 0?
You can't. You can take the square root of 0. Square root of 0 equals 0. Okay?
Oh.
In other words, 0 is part of the domain of anything inside of a radical. Okay?
Okay.
What you can't take is the log of 0. When you have the log of x, x has to be greater than 0. It cannot be equal to 0. But when you have the square root of x, x merely has to be greater than or equal to 0.
Mm-hmm.
All right, what else you got?
Here's one.
Okay.
Crap, hold up. Alright, so it's like a word problem, I guess.
Okay, that's fine.
So it's... Alright, determine whether the given numbers represent the lengths of sides of a right triangle. And it's 7, 25, and 24.
Okay. If those are in a right triangle, which one is the 25?
The hypotenuse.
Yes, the hypotenuse is always the longest side. Which one is the 7?
The
The
one on the left?
the
Yeah, the shortest one.
short side. There are 2 short sides, okay? In other words, there's only 3 sides. One of them's the hypotenuse. The other 2 are called the short sides. Well, that's clearly the shortest, which makes this 24. Now, if that is a legitimate right triangle, what has to be true?
So it has to equal 90, wait, what? 90 degrees?
What's
Or
this thing called right here?
Pythagorean theorem.
Okay, so it has to fit that. If that is not true, it's not a right triangle. Okay? So how can I prove this is true? What do I have to plug in?
So A would be 7 squared plus 24 squared equals 25 squared.
Is that true?
Well.
Let's see, that's 49. You have your calculator? I don't know what that is. I know it's 625.
576. So yeah, that would work.
It does work. And that is actually one of your, that's like the 4th largest perfect Pythagorean theorem, with the first one being a 3, 4, 5. And the next one they expect you to know, or that it's very useful to know, is a 5, 12, 13. And then I think there's a 8, 12, 17, forgetting one of them, but this is the next one up after that.
Mm-hmm.
So it's useful if you know them, because then you don't have to do all this math. In other words, if you don't recognize the perfect Pythagorean triangles, then you have to go through the Pythagorean theorem. But if you recognize them, and all multiples of them, it's not just a 3, 4, 5, but it could be a 30, 40, 50, or it could be a 6, 8, 10, as long as it's in those ratios. All right, what else you got? What other kind of triangles?
I don't have another one of those.
Well, let me give you one.
Okay.
Am I going to prove whether that is a right triangle?
All right, so it'd be
What would have to be true?
11 squared plus 14 squared equals 17 squared.
If that is not true, then it is not a right triangle. It could still be a triangle, but it's not a right triangle. In other words, it works both ways. If you have a right triangle, the Pythagorean theorem applies. But if the Pythagorean theorem does not apply, you do not have a right triangle. Okay? Now, I pulled these three numbers out of midair. I doubt that this is true. So we would say, no, that would not be a right triangle. I won't make you go through the squaring of it. It'd be funny if that is one, but I would have heard of it by now. Those are small enough numbers. So what else you got besides right triangles? What we got? We got another 7 or 8 minutes?
Okay, here's one. X equals root 5x plus 6.
Like that?
Yeah.
These are too easy. Now let's go ahead. You do this one for me. What's the next line?
It would be x squared equals 5x plus 6.
Next line.
X squared minus 5x minus 6.
Is this an equation? Hold on. If it's an equation, it needs an equal sign and something on the other side.
Equals 0.
Okay. Now what?
Factor that, so it would be x's, and then it would be 3 and 2, negative 3 and 2. Or negative 3, positive 2. Wait. Hold up. Or no, it'd be 6 and... It would be, negative 6, positive 1.
Good. Which makes your solutions
6, negative 1.
And usually if you just have one radical sign, then both of them are going to work. And they do here. In other words, square root of 36 is 6, and the square root of 1. Hold on. I'm wrong. Does this solution work? Is negative 1 equal to the square root of 5 times negative 1 plus 6? That is the question. And it does not matter what this is equal to. The square root of a number is never negative.
Okay.
So we immediately know that this is not true, just by noticing that that's a negative number, which makes that not one of the solutions, and this is the only solution. It's a good problem because it illustrates that you can have a solution that is called extraneous. Once again, both of these do not have to be equal to 0. Only one of them does.
Okay.
Okay, here. Let me give you a little tougher one in the last few minutes and see if you'd know how to solve this. Just going to make it up off the top of my head.
Okay, so you would square both sides and put everything in parentheses on the right side.
Okay, so we square the left side, you get x plus 2. What do you get when you square the right side?
2x minus 3, and then 6, or plus 6, root 2x minus 3.
Remember, it's 2 times.
Or 12, 2x, or root 2x minus 3. And then it would be just plus 36.
Good. Now, notice that we have taken 2 radical signs and reduced it to 1 radical sign. That's the key. Because what we're going to do is we're going to isolate this radical sign. We're going to get rid of everything else by moving it to the other side. And then we're going to square both sides again. And that's how you would solve these.
Alright, so it'd be, so it would be minus 2x. So it would be negative x plus, alright, so it would be...
I'll help. Minus 31.
Okay. It would be, yeah, minus 31, and then it would be,
Takes care of that.
Equals 12 root 2x minus 3.
Okay, again, I made this up off the top of my head, so it's not going to come out with nice round numbers. What's the next step?
Square both sides.
No, got to get rid of that 12 first.
Oh, okay, so wouldn't it be...
We're trying to isolate that right there.
So it would be 144 parentheses 2x minus 3.
Well, okay, or we could just get rid of the 12 before we square both sides.
Oh, yeah, okay.
That's the more normal way of doing it.
Okay.
All right, now we're going to square both sides, and the right side becomes correctly 2x minus 3, but the left side becomes more complicated. We can still square that, but it becomes, like I said, more complicated. But we have eliminated the radical sign. We can still combine like terms. Doesn't even become a quadratic. It stays linear, and we're in good shape.
Mm.
Okay? So that's how you handle when you have 2 different radical signs.
Okay.
Okay? Blake, you good to go for tonight?
Mm-hmm.
We'll talk to you next time.
Thank you. Bye.
All right.